Okay, we are going to be looking at 6H today from the Unit 1 and 2 Cambridge Methods textbook. So this is focusing on understanding the forms and features of cubic graphs. So the basic form that we started off with was looking at y equals ax cubed. So this is the standard cubic that passes through the origin. Then this same graph again is the standard cubic, but with some dilation and translation, so some stretching. And we've also got the factorized form with all of our x-intercepts, and we've got the general form, and so which is ax cubed plus bx squared plus cx plus d. So the first thing we need to do is work out what form we are needing to use to find the rules. So an example, if we've got a cubic that has the form y equals a, x minus h to the power of 3 plus k, we're going to use the point of reflection and we're going to substitute one other value, x and y, to solve for the a. So in this case, if we're told that we have f of x is equal to a, x minus 2 to the power of 3 plus 2, and we've got a 0.310 that lies on the graph. Find the value of a. So because we know that we have a value of x, that's 3, and a value of y, that's 10. If we put those values in, we're only left with our a. So I'm just going to substitute those values in. So that means I've got 10 is equal to a, in brackets 3 minus 2, in brackets to the power of 3 plus 2. I then solve. This gives me 1 cubed, which is 1, so it leaves me with 10 equals a plus 2. That, if I get a by itself, I will then have 8. So the next part, now we know that we've got 8, I am then able to write the rule. So my rule, so I was looking for my cursor, is f of x. Whoops. Unfortunately, I'm using a different laptop so that I don't have a touch screen. F of x is equal to, my a value is 8, and I had x minus 2 to the power of 3 plus 2. Let's look at the next question. This is the same, but this time we've got it in terms of the intercepts form. So with the intercept form, where use the non-x intercepts and then substitute the point to find a. So if it says if f of x is equal to a x minus 9 squared times x minus 4, and f of 5 is equal to 16, find the value of a. So it's the same thing. This is our x value, which is 5, and this is our y value, which is 16. So all I'm going to do is I'm just going to grab my equation, and I'm going to substitute those values in. Then all I need to do is solve it. So 5 take away 1 is 4, and 5 take away 4 is 1. And then 4 squared is 16, so 16 times 1 is 16. That means a equals 1. So then if we go, if f of x, so y is equal to ax cubed, ignore that y, plus bx squared plus cx plus d when given multiple coordinates. So for instance, if f of x is equal to ax cubed plus bx and f1 is equal to 16 and f2 is equal to 30, find the values of a and b. So this is where we are just using our understanding of simultaneous. So I'm grabbing this first equation, I'm substituting my first points, which is when x is 1, y is 16. I simplify that, and that just gives me 16 equals a plus b. I can get b by itself if I want to. b is equal to 16 minus a. Likewise, f of 2 equals 30, I create a second equation. I put in 2 for x and 30 for y, and 2 to the power 3 is 8. and that leaves me with 30 equals 8a plus 2b. I can half it, so it's 15 equals 4a plus b. There's two ways I can solve this. The first way, if we are using ClassPad, I can go into menu and main, going down to keyboard and the simultaneous button in Maths 1. And then I can just type what I'm wanting. Remember, variables are in VAR. The first equation I've got is B is equal to 16 take away A. And my second equation is 15 is equal to 4A plus B. What are we after? We're solving for A and we're solving for B, and I can enter and it's going to give me my answer. Of A is equal to -1/3 and B is equal to 49/3. I can double check that through my working out. So here, if I know I've got 15 equals 4A plus B, we know our B values, I'm just going to plug that in and substitute. I'm going to simplify. 4A take away A is 3A. I will then take 16, I get -1 is equal to 3A, and then I divide by 3 and I get A is equal to -1/3. If A is that, I then can substitute it into B. Negative and negative is a positive, so I get 47/3, which is what I had on my ClassPad. Write the rule for cubic with inflection at 2/3 and passing through 4 and 51. So because we know there's an inflection point, I'm going to use the inflection formula. Y equals A, x minus h to the power of 3 plus k. So from this, I'm going to put in my inflection point of h and k. So I've got now A in brackets x minus 2 to the power of 3 plus 3. I know I've got one x and y point. So I've got 4 is x, 51 is y. I just substitute those values into my equation and solve for A. So that gives me 2 cubed, which is 8. So 8A. I take away 3, and then I divide by 8 and get 6. I put 6 into my equation, and I've got 6 in brackets x minus 2 to the power of 3 plus 3. Same thing. A cubic has x-intercepts at -2, 0, and 3, and passes through 1 and 4. Find the equation. So the first thing I'm going to do here is write down my basic x-intercepts formula. The second, what are my non-intercepts? I'll substitute them in. So here I've got zeros, I've got x on the outside, intercept -2, so I've got x plus 2, and 3, so that's x minus 3. Now, the same thing as what we just did. We need to find A. To do that, we need to substitute A point in to find out what that is. So I've got 1 and 4. I grab that and I plug it in. As soon as I plug it in, I can then solve it. A times 1 is just A. 1 plus 2 is 3. 1 take away 3 is -2. That gives me -2 times 3 is -6A equals 4. I then get A by itself by dividing by -6, and I get 2 over, so -2/3. And I just rewrite my equation. So everything is always going to be the same with this. The major thing is we need to know what formula we are using.